Okay, for the next one, again, you're going to need to use your calculator, and here's the clue that it's a calculator question, is look at the decimals in your answers here. So I would make this y1 equals 3 sine 5x minus 1, and then I would use my zero method to try and figure out what those intercepts were. So the place that I find them at now is, let's see here, if I had a little, you definitely want to change your window. Your window, if it was from 0 to 2 pi, then it's going to be quite cluttered. This has a graph, has a period that's going to be 2 pi over 5. So it'll be nicer to look at a graph which is not as cluttered. So I'm going to change my window to be 2 pi over 5. And basically it looks kind of like this. And here's a half. So the two solutions that I'm looking at are these ones here, a little more than a half, and that first one. So it's going to end up being these two values that are my two initial solutions, and 0.56. And the period of this graph, we just said, it has a period of 2 pi over 5, so it's definitely this one, A, because it has the correct period for the general solution. This one does not have the correct solution for the general, sorry, the correct period for the general solution. Okay. To determine an equivalent expression, well, this one's pretty straightforward. If we just rewrite them, 1 over cos theta times cos theta over sine theta, fix those, times sine theta, well, then these would all disappear, and all I'm left with is 1. Okay, so A. Okay, so there are no obvious identities here, so I'm going to try and rewrite this with fractions. So sine theta over cos theta. Sorry, that group in the back there, you guys, you need to hold it together or you're going to be split up. Cos theta over sine theta. And if I make a common denominator, this isn't a trig proof. You don't have to do this nicely and presentably. So you can skip steps as long as you're comfortable with it. If I make a common denominator, I get cos squared over cos theta sine theta, which of course is just 1 over cos theta times the sine of theta. And that's unfortunately not one of my choices. So what I could do though is split these up into 1 over the cosine of theta times 1 over the sine of theta, and that is the secant times the cosecant, which is one of my choices, C. We've talked about these ones as well. When we're moving back and forth, the pattern we're trying to match up to is from this identity. So we're going in this direction here. And what it says is the number in front is going to be halved. And the angle is going to be doubled. So if I apply that pattern to the question here, that means 6 sine 8x cos 8x. I'm going to half this value, and I'm going to double the angle. So the answer is going to be D. For 12, we should first factor out that 4. And again, we want to think about how to go from the cosine of 2 theta to 1 minus 2 sine squared theta. And we're moving this way where we're going to double the angle. So it'll be 4 times the cosine of 12x. Okay, this next identity, you should recognize it as a cosine identity because it has same ratios. It's going to be a cosine and it's going to be a sum because the sign will change here. So this is going to be the cosine of 3x plus 2x, which is also known as cosine 5x. For the next example, you're just going to have to expand it. So this would be cosine pi sine 2x. The sign will, oops, sorry, going a little fast here. Cosine pi cosine 2x. The sign changes, so plus the sine of pi sine of 2x. This is 0, and this is negative 1. So I end up with negative cosine 2x. Sorry, negative cosine 2x. Sine disappears because sine of pi is 0, so that whole term would disappear. Okay, so the last two questions, we're going to have to start by factoring it. So this is going to be, however you decide to factor, of course, that's fine. But factoring is only part of it. So one way you could do it is like this. And then don't forget, if you do it this way, you have to rebalance everything. Okay, so that gives me two equations to solve. One where cos x equals 1. Okay, so if you like the graph, that'll be right there at 0. So x equals 0, or if you like the unit circle, that's right here, and the angle is x equals to 0. Okay. The other equation is this one, which is 2 cosine x plus 1 is 0. So I'm looking for where cosine x equals negative 1/2. And the triangle that I'm talking about then would have to have a 1 and a 2 in it. So it would have to be this one. And pi over 3 is the one with the adjacent and hypotenuse. So that'll be my reference angle. If I'm negative and cosine, this one's a negative. Whoops, this one is a negative. So it's going to be in quadrants 2 and 3. That means this is 2 pi over 3. And this is 4 pi over 3. So the three answers that we would list for our final is that x equals 0, 2 pi over 3, and 4 pi over 3. The last part is to do the general solution. This graph cosine, it has a period of 2 pi. So we don't need to write down the 0. We can just say 2 pi n. 2 pi over 3 plus 2 pi n, and 4 pi over 3 plus 2 pi n, where n is an integer. Okay. So it looks like we're running out of time to do that last proof. So I think I'm going to have to stop here.